to the next video. In today's video I will show you how to do image labeling in native Android app using MLKIT. So first of all, I have created an Android application using the old view system, but you can use Jetpack Compose as well. And here I have added all the camera permission as well as write external storage. You don't require this write external storage, but I have just added it. And I have added camera permission, and for image labeling you have to add this as well, metadata. So there are two ways of including an MLKit library. One is using the TensorFlow Lite model within your app, but that could be little heavy. I think the TensorFlow Lite model are from around 3 to 5 MB of size, so it might increase your APK size. But this way what happens is that whenever your app is installed, the app will download the TensorFlow Lite model from Google Play services itself. So your app won't come pre-bundled with TensorFlow Lite model, which is great. I'm not sure at what point it downloads that MLKit model. I think it downloads at the time of installation itself. So you have to add this metadata. Next, inside build.gradle, here you can see that I have added all the CameraX permissions, as well as I have added this MLKit image labeling library as well. Next, inside activity underscore main, I have added this preview view which will show our Android X camera, as well as inside build.gradle I have also added this build feature view binding equal to true. So you have to add this within the Android tag. So build features view binding true. Next, inside main activity.kt, here I have defined our view binding, and we have to provide process camera provider as well as image capture. Next, I have defined a camera executor as well as the image analysis for each frame which has been captured. Next, here we have defined our image labeling variable as well as initialized it. You can change the image labeler options to whatever you want. Next, here we have set the content view. So because we are using view binding, we have to use it this way. It's not necessary to use view binding. You can just use find view by ID. That is fine as well. And I'm first checking whether all permissions have been granted or not. If yes, start the camera, otherwise request permissions. And here I am creating a camera executor as well as the analysis use case, and we are processing the image proxy. Once the image proxy has been once we get an image proxy, we get a media image from it, and we create an input image out of it and pass that input image to our image labeler, and it gives a success listener or a failure listener. And inside on complete listener you have to close this, but in success listener, this is how it will detect what image label it is, what is the confidence as well as what is the index. And if there is a failure, we are just logging it. And here I have defined a method called or permissions granted, which is just a helper method to check whether all permissions has been granted or not. In destroy, we are shutting down our camera executor. If you want to close the camera as soon as an image label has been detected, just copy paste this bit of code camera provider dot unbind all over here. So here you can just copy paste it if you want to stop the camera once an image label has been detected. And this is the callback which gets called when you request camera permission. So same, if permission granted, start camera, otherwise just show a toast message of failure. And here are the required permissions which we ask for. Camera, this is not required, write external storage, but if you want you can write it. And here is the start camera function. So this is like boilerplate code for CameraX whenever you want to start camera. So I won't go much in detail about it, like you have to copy paste this bit of code every time. So yeah, that's it.